Thank you, everybody. That's pretty cool. I'm very thankful to be back in Stockholm here. It's a really great place to be in general, and also a pretty cool conference. My name is Nicolai, but I won't waste more of your time by introducing myself. I just want to get started, because there's lots to talk about. My plan here is to make those of you who are still running Java 8 really envious of what's new. My goal is not to teach you these features, because that's way too much work. Even as it is, I prepared way too much, so I'm going to talk way too fast. Just want to show you how cool these things are, that then you are more motivated to look into them and maybe update. And so there are a couple of links. First of all, the slides are already online. You can go to slides.codefx.org. You'll find it on the right-hand side. And then there are links to various repositories here, so you can follow along if you want at home. And I want to quickly start with a short look at Java 8, which was released in March of 2014. And free support by Oracle. So free by Oracle ended January 2019. But Red Hat, or the community at large, I should say, under the guidance of Red Hat actually, offers free support for OpenJDK until at least 2023. And Java 8 is generally like a good release to be on. It has solid feature set with lambdas and streams. It does have really good performance. It's stable. It still gets occasional backports of nice features that are upcoming. It has good support, commercial and free, so I get it why still many people are on 8. But you are missing out on a few things there. There are lots of new language features that came into Java since then. There are improved APIs a ton. There are many JVM features, smaller and larger ones, performance improvements in certain cases. There's a lot that happened since then, and I think maybe it feels like each release is so small that it felt like nothing much changed, but that nothing could be further from the truth. And so my goal is here to show you that you're missing out if you're still on Java 8. And what I want to do for that is I want to take a code base and then just walk through it and just randomly update things to new features, right? So let's have a very, very quick look at what this does. The idea behind this code base is that I wrote a bunch of blog posts, and I want to have like a recommendation engine, right? That basically does something like it takes the front matter of these markdown files, and then in this case, all it really does, it looks at the tags and figures out which blog posts have which tags in common. So if you read one of those, maybe I can recommend to read others. That's what this program does. It actually kind of works. I'm actually going to use it at some point, but not at the moment. I split it into two sub-projects. One of them, it contains most of the actual code. You can see the package here. Article is basically containing all the business, all the domain objects, like the article, and then you have a slug, which is like the part of the URL. You have a date, you have tags, and as you can see, it's reflected. The class names are reflected in the front matter over there, right? So you have, let's see, you have a slug here, and that would be then that slug, and then the date and the tags and so forth, right? So this is how we capture an entire article. Then we do some kind of analysis of how related they are. So that's why I picked the genealogist terms here. A genealogist is really something very simple. Just give it two articles, and it infers some kind of relation, like how related are these two articles. And we have an indirection here with a service. I'm coming back to that in a second. And then some other stuff that we need here that's not terribly important at the moment. This is basically kind of like the public API of this project, really. Then we have genealogy, which just takes all of this stuff and just does the actual analysis. That most of that happens here, right? So you have a lot of articles, you have a lot of genealogists, right? You could compare stuff by tags or by dates or by, I don't know, like the content of the blog post, by pretty much anything. This is why we have many genealogists, because one of them might do one comparison, another might do another comparison. And you have to weight them, like maybe tag analysis is more important than something else, so you want to weigh the results, and that's what this class really does. And then in the end, we spit out some recommendations. So given a bunch of relations and how many articles do you want to recommend per article, right? So like the 3 most related articles or the 5 most related articles. It gives you back a stream of recommendations. And you can already see that I'm a fan of using streams in method signatures as a return type, but also as a parameter type. I know that's up for discussion. It's just something that I personally prefer doing. If you don't like that, don't let that detract from the rest of the talk. And then really most of that, which is up here, main, just binds all of this together and executes it. Right? So this just reads the configuration and then creates this genealogy stuff, and then at some point it will just infer all the relations and then recommend a bunch of articles and put that into JSON and write that. Okay, well, that worked fine with the clear. Let's run this. I have a short script here which basically tells which Java version it's running on. Now it's building with Maven. It takes a couple seconds. Then it runs the program 10 times. It's really fast because it's just 130 blog posts, some things. And then it gives us some information down there. It tells us that we took like a second on average to run this, 1.1 seconds. This is really unreliable, right? So we're going to see maybe some performance improvements, but this kind of measurement is very unprofessional, and so it's very unreliable, right? Don't take this as a your application will get 20% faster kind of thing. But what we see there are also some statistics about the code. Most importantly, maybe the lines of code. So we start with about 1,650 lines of code, okay? Now let's move on. Let's start going to Java 9. So the first thing we do, I can recommend using SDKman. So you can easily switch on the command line. So let's switch to Java 9 here. There's that. Now we're using Java 9 on the shell. And now we have to tell Maven about it as well. I know people are afraid of the Java 9 update. Look how easy it can be. There you go. There is 9. We re-import this. We go to the properties, which opened on a different, there we go, on a different screen. Wait, there's the project. That's not, there we go, okay. Pick JDK 9. Yes, I want to use Java 9 stuff. Where is it? Somewhere up there. There we go. Okay. Let's see whether that worked. That should be the Java 9 update here. Maybe. Building, and yes, nice. See, Java 9 update, easy. Okay, now let's start actually doing stuff. So the first thing I want to do is, I told you earlier that we have this genealogist, which actually does the work, and we have this service, we have this indirection here. And the reason why we have this indirection is because in the project up here that I didn't discuss before, this is where we actually plug in the implementations of the genealogist, right? So one of them is really silly. It just counts letters in the title and compares them by letters, which surprisingly leads to surprisingly good results, actually. And this one actually does the tag comparison. And at the moment, we use a meta-inf services file to make the JVM aware that the tag genealogist service provides the genealogy service, right? So this worked before Java 9 and without the module system, but I still want to introduce the module system for a couple of reasons. One of them is, remember earlier when I said that this is kind of the public API? But the thing is, there are public classes here. And they have to be public because I want to use them from a different package. So really anybody can just start using genealogy classes. That's not good. I actually want to protect this internal API. And to do that, I can very simply, or start down here actually, create a module declaration. So there you go, module info Java. We're going to call it, give it a proper name, which is the package name reversed. So it's somewhat unique globally. Java after 8. I'm going to steal this here because we use it a couple of times. That's the name of the module, and exports a couple of packages, namely the one with the articles, and, exports. And then also the genealogy one. That should be that one. And it uses actually Java management. We'll see later why it does that. We're just going to trust me for now. And it uses a service, right? It uses the, the genealogy, sorry. Yeah, I make a lot of typos. I'm sorry, it's just a thing that I do. Genealogy, no wait, that's the wrong, is it right? Genealogy, sorry, that's the wrong package. Oh yeah, it's up there, the wrong package as well. There we go, okay. So this means now the module system knows that we're planning to use that service. That's pretty good. We can now start interacting with that here. Create a module info Java over here. That's already a good name. There we go. We require that other module, of course. Requires. Let's see, we often make that mistake. That's the other one we'd require. And then we don't export any packages, actually, because we don't need to. We just want to plug in services. So we just say, OK, it provides the genealogist dot, no, wait. Singular genealogist. It provides this service with the following implementation, which is now the implementation comes from over here. I'm looking for this one. So it's in tags dot. There we go. That's the service. Okay. I think let's cross fingers and hope this is right. I already know that it's not quite right because I'm using JUnit 5 to run tests. And so classes don't have to be public. And also some of the tests reside in packages that don't export it. And at the moment, unfortunately, that means that when JUnit tries to use reflection to get at the tests, which are somewhere down here, I actually do get run build errors, which you can see here. And we don't want to have those, right? So at the moment, unfortunately, Maven Surefire plugin doesn't do that yet. I thought it does. Maybe I just misconfigured something. But at the moment, it doesn't for me. So I have to go into the POM here and then tell the Surefire plugin, I just copy-pasted this from off-screen, to open a bunch of packages. That's annoying, and I think it could do that. And as I said, maybe it does. So don't take this the wrong way. And now I hope that this actually kind of works. And also, what I didn't show you yet, I also changed the build script, right? I didn't do that here yet, actually. But we can. Let's do that. So the script that runs this is this small one here. And some stuff aside, this is the important part where we run Java. And as you can see, I'm still using the class path here. And I have to actually iterate, like enumerate the individual jars, which is kind of annoying. So let's not do that anymore. Let's instead use the module path. And the amazing thing about the module path is that it knows what a directory is, and actually knows that it can look into directories to look for jars there. That's pretty cool. And let's start with the module genealogy. I think that was the right name, right? So this should also work now. So now we're using the module system. See another scary migration we just did with a just hand wavy way there. But Java 9 is more than the module system. If you like the module system, by the way, I wrote a book about it. I have one free copy here. If you want to have it, come by later. But that aside, there's more in Java 9 than the module system. There's a ton more, actually. And I want to walk through that as well. One of the interesting things is the collection factories, right? So once again, let's move this over here so you can actually see it. Let's have a full text search for arrays as list. Arrays as list, because I use that quite a lot. You see, like, you always kind of want to have something like here, for example. I just want to have a list with these entries for tests, for example. And you always kind of go with arrays as list because that's the easiest way to do it. But it's awkward. It's somewhat unmodifiable, the list you get back, but not entirely. While you cannot add elements, you can set elements on an individual index. So that's just weird. And why are arrays involved at all? Java 9 have the collection factories, so you can just say list.off. The same thing maybe with sets. So basically, I can go through this, and every array as list really should be should be list off. So there's a ton of improvements that are possible here, right? All of these are like very straightforward to do. List off, right? There you go. But there are some more some ways where this can get even better. Once again, everything's on the wrong screen. That's annoying. Let's see. Hey. Come on, IntelliJ. Never mind. I'll just go into this class here. And so, wait, that's not the right one. That's the right one. There we go. So what do I do in this constructor here? I want to create one of these weights for the tests, right? Because I need it, apparently. And the way I'm doing this here is I create a new hash map and then put stuff into that hash map. And I need this entire constructor just for that, just for being able to fulfill the hash map before I can start using it. Look, we don't have to do this anymore. I can just say, look, I want to have a map of these elements. So we start like this, and then we use some multi-line editing. There we go. That's that. So now we have map.off. And now we don't need this. We can do this inline, right? So we inline this variable. And then we see that we don't need anything of this anymore. So we can just move all of this out of the constructor, get rid of the entire constructor. And there we go. So we'll just do it this way. And that's actually quite a common thing, right? You have, let's say you have a data structure, like a list of, let's say, some default fallback IP addresses or whatever, some URLs, all kinds of things, really. And usually you have to get a static constructor or static initializer just to fill that stuff, right? But you don't have to anymore. Like this, being able to get rid of static initializers or constructors is not uncommon. That happens a lot if you start using these methods. Let's go back here. For example, in tests, you do that a lot as well. Like here, I need a map with just this one entry, so I have to create it and then put stuff in there. That's way more complicated than it has to be. Can just be map.off, just this pair here, and there you go. You can't do that. You can't use that everywhere. Anywhere. Here, for example, I put null into the map. And the static factories there, they don't accept null. For good reason, so here I have to keep this around. Okay, what else is new? There's a really cool new method, two methods on stream. Let's go into the article factory. This thing looks at a markdown file and tries to extract front matter and content from that markdown file. Now, if we go back somewhere down here, there was a file. Let's see whether we can still find it. There you go. The markdown file, this is what's called the front matter. It's really YAML, but I don't want to use a YAML library just for this simple parsing. I can do that myself. And it starts and ends with these 3 dashes. So imagine you get a list of all the lines in that file as a string. How do you get to just these lines? Well, the imperative version is what I did here. You actually have a Boolean variable that remembers whether the front matter already started, and then you go through this, and then while it didn't start yet, then I'm looking for that line, and then I remember that it did start, then I start remove. That's a lot of code, and it's not very trivial to understand. But look at this. We're just going to use a stream API and say, while you didn't see the front matter separator yet, so let's take a line and say, why did not yet equals the line, drop individual stream elements while this did not yet happen, right? So if there were lines before these 3 dashes, they would just get dropped. While we didn't see that thing, as soon as we see it, drop while changes behavior basically. It says, okay, we saw that thing, so now we stop dropping lines. We still don't want to have the first couple of dashes there, so we skip the first line, like the next line basically. And now we're going to take lines until we see the closing 3 dashes, so to speak, right? So now we take lines while that happens, and now we unfortunately still have to collect to a list. There you go, now we collect to the list, and that replaces all of this. And it's arguably, once you know how to read drop while and take while, much more succinct, much clearer to read. It just really tells you what's happening. Here we are looking for the content. So we're doing basically the same thing, but we're going for after the second dash. So it's kind of similar, but we want to drop lines until we hit the first dashes. Then we want to skip that one line. Then we want to drop more lines until we hit the second set of dashes. Then we want to skip that line as well, and then we take the rest into a list. What you can do now is actually you don't have to operate on lists anymore. You can start taking in and returning streams here, which I don't want to do now. But if you do that, then this part becomes lazy, right? Beforehand, I had to collect all the lines of the file into a list. I had to eagerly read the entire file just to be able to extract a front matter. If we use streams all the way, you don't do this anymore. You just stream through the file until you hit this, basically. Until this one fails for the first time, because we arrived at the second set of dashes, and then we just collect those, and then we just return that stream. So this becomes lazy then. That's pretty cool. Now, then there are a couple of things that are new and optional. Let's go to the main method, main class, which basically binds all this stuff together. I'm pretty sure you've occasionally written code like this. Output file is an optional, and it's like, if it's present, then do this thing. And if it's not present, then do that thing. And this is kind of annoying, because if it weren't for the else branch, we could just use config output file if present. You already see it there, right? So we would have used if present, but then we don't have an else. But in Java 9, we get an else, in Java 9, we get an else. So sure, somehow we can type this out. There we go. So now what do? We basically say, if we have a file, then do this thing. And I think, wait, we have to put the file here. Let's see whether we can get all the compilation errors out. That looks good. And if we don't have anything, well then, we don't have information. So we start with the empty parameters, and we print this. Oh, I didn't look into the recommendations yet, but I'm going to do that soon, into the resulting file. Oh, so there's that. So now we can use if and else both in this more functional approach. Also, arguably, the else part is not really that functional, because we don't have any input. So it just has to have a side effect. But there you go. Another really nice thing that let's go up here. Let's go to these process details. Remember that it printed the Java version it's on, and then also the process ID. That's what's happening in here. Let's have a look at that. Let's have a look at get process ID. So getting the process ID is kind of painful, right? There are like tons of different methods, and some of them work on some JVMs and others don't. So what you basically want to do is you have a bunch of methods, and each of them tries something and returns an optional, being like, okay, if I succeeded, here's the process ID. If I didn't, I'm just going to give you an empty optional. And you want to chain these. And chaining optionals is actually not easy in Java 8. You have to do something like this. You have to check and then return, and then otherwise, because this or else variant, if you say optional or else, then you actually fall out of an optional, right? You then have to provide a specific value. And Java 9 adds a small method that gets rid of that called or. So here we can just start returning stuff. We can just say get the process ID from the MXB name, whatever that is exactly. Or, you know what, do this. Do process, there you go. No, process details, code completion, hello, no? I'm sure there's a typo there, but I don't quite see it. Get process details, plural. Okay. Or do this. Or do the other stuff. That's internal, we already have that. Let's say this one is the next. It doesn't really matter what exactly is. Actually, they all work on my machine. So I went through a Stack Overflow question, just picked out the ones that looked like that make sense. Okay, so here we go. That's also, by the way, where we use the Java management module, because something in here, I think this one, the management factory, comes from there. So that made the code shorter, and once again, more readable by making it shorter, because it more clearly expresses what I want to do. But the really good thing is, actually on Java 9, I don't need any of this. So like the entire trying to get the process ID from some kind of, asking the operating system for some weird Linux file, then that's totally unnecessary. You can just have process handle, give me the handle to the current process, and now look, took Java 20 years. Process ID, there you go, amazing. It's like true innovation right there. And the same is true, by the way, for the Java version. I mean, this already is a pretty good way to determine the Java version. A less portable way is what Log4j1 did, and not harping on these maintainers of these projects, right? They made the best decisions they had available at the time. So Log4j1 fails on Java 9 because it tries to figure out what Java version you're running on. And it knows that Java versions start with 1 dot. So it throws away the first 2 characters and then parses the next one. So the thing there is, when Java 9 came out, the version was just 9, like nothing else. So throwing away the first 2 characters and then parsing the empty string, that just broke the JVM and just couldn't launch even with Log4j on the class path. That's not good. Then Java 9.01 came out, and it threw away the first 2 characters, parsed the next string, and then determined, hey, I'm running on Java 0 apparently, so let me turn off this couple of features that would otherwise be available. That's not good. So once again, we finally don't have to do that anymore. Look, another amazing thing you can do. There you go. As the runtime for the major version. Look, the entire class just became superfluous. Just basically just replaced it with 2 actual method calls. So that's pretty good. Now, I didn't do all the Java 9 things, right? I just showed you a couple of them. So I'm going to cheat here and going to check out something off screen. And I'm going to give you basically the full version of all the Java 9 updates. And we can then run this thing again. Remember, we had 1,665 lines there. Let's see what happens here. So basically, it's the same behavior all over. And we just dropped about 100 lines of code. So that's pretty good. Now let's move to Java 10. Nope, we actually do stay here. One more of those scary updates. Okay, I admit, like in a real-life project, sometimes it's a little harder than this. But not much. Like nowadays, if you're able to update all your dependencies, which is really easy because this project has 0 dependencies, if you're able to update all your dependencies, then it's pretty straightforward to update to a new Java version. Okay, now we're in Java 10. What's the cool new thing in Java 10? The JavaScript thing that we got? var, remember? So what we can do is, oh wait, that's not where I want to be. Is it? Oh yeah, it is. Okay, so that's the main class, remember? Look at these lines. Config, 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 create. Like, yes, I got it, it's a config. That's, yeah, I got it. Right, look, this is none of this rocket science. I mean, we can actually start arguing here whether relations should be a var, but relations is obviously a plural. So it's a list or a set or a stream, it's some of those things. JSON is a string, that's a surprise. So there you go. Just like, I think this made the code a little more readable, particularly because it aligned the variable names. So it's very easy to read the variable names here. And you know how we all develop selective reading skills, where you can just opt into just ignoring keywords? So that's pretty good here. You can just like ignore the var and just read the names there. So I think that's pretty good. In the full version of this project, you will see a ton of var all over the place. In some places I use it, and some places you don't. There's a big discussion of, well, not a big discussion, but there's a big trade-offs involved on where to use it and how much to use it. And I'm totally glossing over all of this here. But the feature's there, and in general, it's a pretty cool thing to use. Now let's go to another class, and let's use something more with collection factories, because they got extended in Java 10. Look what I'm doing here. I get a map in, and I'm making a defensive copy of that map. And then I check whether it doesn't contain nulls. And then I'm never touching it again, right? I'm never adding anything. Most of this code, like I think almost all the classes are immutable anyway in this project. So what I'm really trying to do here, but what I couldn't simply express before, is like I just want to say, look, this new map is just a copy of the old map. Typos aside, damn it. I'm getting there. Bear with me. There we go. Okay, nice. Right? Much more expressing. It does the same thing. It just creates a copy, and it makes sure that there are no nulls in there. Another cool thing is that it does is, if weights is already one of these immutable or unmodifiable, depending on what terms you want to use, maps, then map.copyof does not actually create a copy, because the original version is immutable, so nothing can happen, so it just hands you back the same instance. So that's pretty good. Collections.unmodifiable list and set and stuff, they don't do that. They always add a wrapper to that. And map.copyof doesn't. So that's pretty neat right there. You can also have these two list collectors. This one, for example, return unmodifiable list, which arguably would be the nicer default, because I think in most of unmodifiable, which, as I said, it probably would be better by now to have two modifiable list as a specific variant and be two list unmodifiable by default. But of course, that would be a breaking change, so that's not going to happen. But yeah, so you can have unmodifiable collections here as well. And another thing that Java 10 brought, which I'm not going to show you in detail how to start using that, but I'm going to show you how it looks when you're done, is it's application class data sharing. So the JVM, when it launches, does a bunch of stuff. It just has to, oh, that's not what I wanted to do. There you go. Does a bunch of stuff. It loads all the classes from all the jars, right? And including the JDK classes. Now, it turns out, when you don't do an update, it's actually always the same classes, all the time, and gets read every single launch again and again. And that's one of the reasons why Java tends to be not the fastest one to launch. Now we can use CDS archives. CDS archives is a class data sharing archive. What it basically does is, after the JVM did all the reading from file and did all the bytecode verification and put it into an internal data structure, it dumps that internal data structure into a file and will then later simply memory map that file and just start using it. So we can help the JVM launch faster. And then, generally speaking, 3 steps involved. The first step is somehow come to a list of classes that you do want to put into that archive. Second step, create that archive. Third step, use that archive. The first step, creating the list, we don't have to do for JDK classes, because it comes with a list. And so the second step here, what I'm doing on Java 10, is to actually create an archive from that list, and then I use it to run it. And then here, for the actual application class data sharing, which includes my own class into that archive, I do actually have to create a list first. And let's switch to Java 10 here. If I didn't know, I didn't. Let's do that. And then let's run the CDS script. And first it just runs the process normally. Then it creates the archive just for the JDK classes. That is this part. It runs that. And then it creates application class data sharing archive and does that. And if you look at the runtimes here, we will see it's about 1.2 seconds here. And with the JDK archive, it's about 1.2 seconds, and with the application archive, it's about 1.2 seconds. So in this specific instance, we're mostly just reading files from disk, it doesn't make any measurable difference. But it can be. It can cut your launch times short by like 20 to 25%, depending on your application. So that's pretty cool. Let's have a quick look on the file system and how this looks. We got the CDS folder here. So first of all, I created some application logs here with a new feature called I'm drawing a blank here. It's not unified logging. But anyway, so there's a new way to tell the JVM how to log stuff. And I logged all the class loading stuff here, and you can always see shared objects file, right? So I loaded a bunch of things from the file, but not all the things, because this is the log for the JDK class sharing. So my classes were actually loaded from, well, sorry, from my jar. But some of them were loaded from, most of the JDK classes were loaded from this shared objects file, so that's pretty good. And the archive is just this thing here, app.jsa. And I don't know how large it is. It's relatively small, a couple megabytes, I think. Because that's a pretty good thing that we can start using in Java 10. And it gets easier later in Java 12 and 13. So let's move on. Let's go to Java 12. Oh, sorry, 11 first, right? That's how numbers work. Is it 11 now? Yes. Let's go to Java 11, re-import that. Little song and dance here. I got really fast at making these settings for obvious reasons. There we go. Okay. And now let's see what we can use in Java 11. So I want to draw your attention. Let's actually have a look at the result of all of these things, of all of this program. It creates this recommendations JSON. That's really the output. And it looks like this. For this title, these are the recommended blocks. Okay? Now I already highlighted this one. This is called Java 9 resources, talks, articles, repos, blogs, whatever. Okay. So I want to show you the file for that. And let's see where we can find it. There it is. Okay, so there's this one, right? That's one of them. Now I want to open a second one. Takes a moment to copy paste. Full text search. There's the title. There's this one. Okay, we have these two files, okay? Remember that I said we do the comparison by tags? So these two have the exact same text set. They're the only ones who have this exact text set. So they have 100% overlap of their tags. That sounds like it should be recommended, right? But if we do look at the recommendations for this one, then the other one doesn't even show up, right? So this is Java 9 resources. We're here. We're looking for this one, for the CodeFX Java 9 tutorial. It's not even in the recommendation list. Like, how can that be? That's weird, right? Okay, let's have a look at the text, at the code that creates these. That's this part. It gets the, well, this looks a little odd. Let's do this. It starts with the text, basically, which is this line here, this part of the line. Strips out the opening and closing parentheses, splits by comma, trims all the white space, makes sure that it's not empty, and then starts collecting tags. So why don't, but then they'll have the same text. What's the problem here? And I'm sure you've already spotted it because it's quite obvious. The solution is that this is not a normal space. This is something that trim does not recognize as a white space. I think it's Unicode 2001, Odyssey in Space. I think that's the name of the thing there. That's kind of weird, and that's not actually easy to spot in practice. And if you ask character dot is white space, then it will actually tell you, like, yes, this is a white space. So the two classes, so string.trim and character.is white space don't agree on what a white space is. And arguably, character.is white space does it correctly. So we can now say strip, which is like trim, but better. And we can then also ask you, so is empty basically means after trimming, is it then the empty string? And is blank does the same thing, but with strip there. So there you go. Now this actually works. Now the bug disappears, and we can see that in the recommendations. You're just going to have to trust me. Oh, well, yeah, you're just going to have to trust me on that. As I said, prepare too much, talk too fast. So I'm not going to have time to look into that. There's another cool thing we can do here, though. If you still look at the filter, what does it do? It checks whether is blank returns false, whether it is not blank. But you have to use a lambda here because of this thing. If you want to filter just the empty ones, they were pretty cool. We could use the method reference. Now we only get empty strings, so that's really not helpful. But wouldn't it be nice to just be able to write not this? And we can. So the predicate interface got a static method called not. And you can use it like this. So now we filter if it's not blank. I'd argue that's fairly readable. It's a great improvement there. Another thing that is a little bit uncomfortable before now is if you want to use a path, then the way to get that was paths.get, which is like, if you know it, it's easy. But if you don't, you take some time to figure out, like, how do I even get a path? Like, there's no way to just write new path. But now we can write path of. Small improvement, says 2 characters, but I think it's much more discoverable and easier. Then, quick look at toArray. Which one, though? Let's have a look at these nodes here. Yeah, let's go to config. Somewhere here, I call toArray no collection. So this read all lines returns a list. And but for reasons that make more sense if you look into the entire class, I actually need it as an array. So I call toArray on that. But the list maybe has 20 lines. When I create an empty array, like but with 0 lines, isn't that waste? Shouldn't I just create the array of the right length? Well, that would be kind of uncomfortable to use here, because then I would have to store a field just for that, to put, into a variable and then read the length and all that stuff. But then also it turns out it's not actually faster. Surprisingly, this one is faster. But even more importantly, we shouldn't be bothered with this. So what we can do now, it's a very small change. We can do this, which we know already from the Stream API. Collections now also have this toArray method where you just create an array of whatever length you think is best, and it will just work. So that's pretty good. So that's Java 9 there. Java 11 there. Not too many things were in that, but as I said, I have to skip over a few anyway. So let's start using this SDK, use JDK 11, and then let's quickly check out the full beauty of Java 11 off screen here. There we are, and then we run this. So where were we? 1,560-ish, I think. After Java 9, I think we didn't even check after Java 10, right? So after 10 and 11 in there, still works. Well, another couple lines, not that much. But when you look at the character count, it actually decreased a little bit because of all the vars in there. Not sure whether that's the right best measurement of code quality, fewer characters, but well, at least you can point at something. So Java 12 now it starts to get more interesting. What's the big feature in Java 12? Just scream it. Or you're whispering, that's not screaming. Is it Swedish screaming? It's switch expressions. The really unfortunate thing is that this entire code base doesn't switch over anything, ever. And trying to force it in was really very, very that's not good. We have to keep this on Project SDK. Look, it will break later. There we go. Yeah, so switch expressions. This one doesn't switch ever, so that's unfortunate. So I actually can't show you switch expressions here, but there are a couple of small things that are pretty cool about Java 12, and I want to show you those. One of them is that Surefire doesn't work with it. That's a pretty nice thing. So like no tests can fail. That's always good. But you can make it, like if you absolutely want to, you can still kind of make it work if you have to, update the dependency of Surefire on ASM. So if you move to newer Java versions, that will occasionally happen, that you have to look deeper into your dependency tree and update certain dependencies that are there, because the old version of ASM can't read Java 12 bytecode, and as far as I'm aware, there is no Surefire release with a newer version of ASM. Maybe there is, never mind, it happens occasionally, right? So that's what I have to do here. And then there's another thing that we can do, but I'm going to copy-paste that in because it's not that trivial to walk there. Maybe it's a little bit easier to show you what it looks like if I just drop it in. So relation somewhere aggregate here. So we're aggregating relations here. That means, let's say you had 5 genealogies that returned 5 different kinds of relations, and now you want to put them into one. What we're doing is here, we're taking these relations, we're mapping them to this unfinished relation thingy, and then we're somehow reducing that and mapping it. And the reason for that is that we actually want to do 2 things. One thing we want to do is, each of these type relations consists of 2 articles, and each pair of 2 articles, we want to keep that together, right? We have article 1 and article 2, and in the end, we want to have the same articles for the entire relation. So we want to collect those, basically. We want to make sure that we have the same pair there. Another thing we want to do is we want to average over the entire over the entire scores, right? So each typed relation contains a score of how well how well the relation was. And so the way to do that, at the moment, is you have to somehow drop in a new class, do that there. What you can do if you want, after importing tons of, come here, static methods, yes, more, yes, Yes, mapping as well. So what we're doing here is we're using a new collector called teeing. That's pretty cool. What teeing does, it uses two other collectors. Not look too closely at what exactly they do, it's not that important. There's two other collectors, namely mapping and averaging double here, and in the end I'm combining their result. So that's a pretty easy step to make certain things a little bit easier to express. Now you can say, look, this doesn't look better than it did before. And in this specific case, I'd actually get your point. Maybe I wouldn't do this refactoring, but then again, that means that all of this is unnecessary now, because that was the unfinished relation that we used earlier for that. So that's kind of nice. Okay, there are a couple more things in Java 12, like improvements to class data sharing and to completable future. I don't want to go there at the moment. So what we can do instead is we can already move to Java 13. What's the big feature in Java 13? Oh, that's not the right thing. Yeah, exactly, text blocks. So you can now have multi-line text. You could do that before, but now it's actually easy. So let's move to 13. Yep. There we go. And let's have a look at main, because main creates the JSON output in the end. And at the moment, it does it this way. Right? Of course, I could have used just a JSON library, but why would I use a library for just a couple lines of code? And that's not very comfortable to read. Like there's a line break here, and it's hard to spot whether this is correct or it's not it's incorrect. This is where text blocks come in. I think at the moment IntelliJ will start complaining because I don't have that turned on yet. Let's turn it to preview. Does it work now? Yes, it works now. That's good. I just want to show you the one. Oh, we need that thing there though. Never mind. I'll just check out the proper version later. It already helps me here and says, like, look, maybe you want to turn this into text block. Look how much easier, how much more readable it is. That already helps a lot. A couple of things happened there. The new lines are gone. And then also because the single quotation mark is no longer special, those escapes are gone. And then I can replace these tabs with just actual tabs, because we all know that's the only true version of indenting stuff. And I'm happily going to fight you over this later if you want to. So there you go. Much, much more readable. Now you actually can see what's happening here. Well, that's not entirely correct, though. Now it is. But yeah, there you go. That's one thing. And now for the coup de grace, let's move to 14, which is, of course, still early access. Yeah, we're not running this. We're just going to go to the POM there. Last one. Last time I have to do this. While practicing this talk, that was the most annoying part, continuously walking through these menus. There you go, that's 14. 14 records. Records are amazing. So, yeah, you know what? Let's do that here. We have a compile error here, but we're just going to ignore it for the time being. Let's have a look at some simple classes. Let's have a look at the description class. What is it? The description, well, that's the description you get in the front matter, right? It's just a little bit of text. It's just a wrapper on a string, really. You could just use a string, a blank string, but I call that stringly typed code, because that's actually, you only can confuse the description for the title, because both are strings. That's not a good thing. So I want to have this as a class, but this is really very simple. All it does is has a field, has a constructor for that field. Well, we're going to come to that method in a second. It has a getter for that thing. It has an equals, it has hash code, it has a toString, and all of that. And now enter Java 14. I'm going to have a record, which I think I have to unlock first. And then we tell this record that it's containing a text. And then we don't need any of this. Well, we don't need any of this, because JVM generates all of that for us. The compiler, actually. So there you go. We just dropped a ton of lines of code, made everything much more clear. Like, it's a description, it's just basically a wraparound text. Now you can read that. And this is so common. This specific code base, the entire package up here, article, like all of them basically are records. It's just a small wrapper around that data. I think that happens a whole lot. I think in DDD there's even a term for those, right? For these domain objects that are just work like this. Don't quote me on that, though. So there are a ton of things that you can do with this. I want to walk you through. So first of all, this is a regular Java class. You can still do all kinds of stuff. So for example, let's have a slug here. This implements an interface. That's not a problem. You can still turn it into a record. This is a record which has a value, string value implements an interface. We still need the static factory method there. Now all the constructors become public. That's unfortunate, but oh, well, actually, we should not remove the method that implements the interface. We need that one. There we go. Okay, so compared to we still need. And as you can already see, I can still override the getter, right? So it doesn't have the get word, which I think is a great decision. I didn't like it anyway. I stopped using it a couple years ago. So I can still overwrite it. I can still do stuff in here if I want to, but I don't have to. I can just leave it to the JVM. And one of the dirtier things you can do with that is you can have a look at this here. We have a stream pipeline, and as it happens occasionally, you're putting stuff together to keep information around. In a stream pipeline, there's really no good way to do that. Like basically you map from one type to another type, you lost the initial information, right? But if you want to keep it around, you basically need ad hoc a pair of both of these. And that's hard to do. So what I did here is what I had to do. I created a small static class which has 2 articles, and then this one, which is it's the same thing, but it's articles and a genealogist in there. But this is just a record as well. So what we can really do, we can just say, this is a record. And I don't want to show you the full thing. So we're going to leave it with a couple of compile errors. I just want to show you what it looks like. So we can do this. But now it gets better. Well, it gets different. Did you know that you could do this? This actually does work with classes too. You can have method local classes, which usually is a ridiculous proposal because you want to have short methods, right? Why would you dump in an entire class which takes up 10 lines to declare? But here that makes sense. It's just something that I use here, right? So I can just declare that here. The other one at the bottom, it's just a second line in here, and there you go. You have the entire thing like on its own, self-contained. And if you need to pop it out, it's just as easy as this. So that's pretty good. So to finish this, let's run this entire thing on Java 14. Once again, I'm going to check out the actual final version of all of this, and then we're going to run it. We started with what, like 1.1, 1.2 seconds, if I remember correctly. As I said, these measurements are somewhat unreliable, but we still see some kind of improvement on the runtime as well. Well, we don't, so there you go. But sometimes we do. But we dropped 400 lines. That's a fourth of the code base. And nothing of what I showed you was really making the code harder or more complex to read. Everything, to my opinion, became clearer by being expressed more clearly. And that to me, that's pretty amazing. So that was all the code I want to show you today. And there are a couple of things on here that you can go through if you want to. There are a couple of information on the versions, what features I've shown you, what features I haven't shown you. Right, so there's still way more in there. I don't want to show you this all of now because apparently you want to get lunch, I guess. Just so there's tons more stuff in here that I couldn't show you possibly, including the switch expressions, for example, which are really nice. So there are tons of things that you could still do here. I didn't show you the improvements to application class data sharing either. There are tons of more improvements. And what I impress on you is that we got strong encapsulation, we got safer code, more expressive code. It runs faster some of the times at least. The JVM has lots more features. And it's not that 9 was just the module system and nothing else, and everything after really didn't do anything much. Nothing could be further from the truth. Java removed a lot after 8, and I really hope that you do too. Thank you very much.